Good afternoon and welcome to Carlam Cymru revision sessions. This session will focus on the higher tier Maths GCSE and will be presented by Mr. Alan Walters from Gowerton School. The session will last around 45 minutes, where Mr. Walters will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your question during the session. The session will be recorded with the recording and any relevant resources uploaded to the e-sgol website in the Carlam Cymru area.
Hi everyone, today we're going to look at direct and indirect proportion. First of all, we'll look at direct proportion, and I've written a few notes. If two variables are related in such a way that one of them is a constant multiplier of the other, for instance, y is equal to 4x, then y is said to be directly proportional to x. The constant multiplier in this case is 4. I won't say any more than that. Y and there's x, and if one is directly proportional to the other, then the straight line passes through 0, 0. Okay, there's more there you can read in your own time. Okay, we'll crack on with the questions. 4 main things you've got to look out for. The first one, if y is in direct proportion to x, then y is equal to k times x. And you've got to know that to be able to start the question. So if I said if y is in direct proportion to x squared, you would say y is equal to k times x squared. Likewise, if y is in direct proportion to x cubed, it's y equals some constant times x cubed. And if y is in direct proportion to square root of x, then y is equal to some constant times the square root of x. Okay, remember that in each case k is different. Okay, and that's what we will be working out first. So I think we'll crack on with the sort of questions that you could have. So for the first half of the lecture, we're going to look at when y is in direct proportion. So the first question is typical of a GCSE question. The table below shows a set of matching x and y values, where y is directly proportional to the square of x. So the first thing I would write down is y is equal to some constant times the square of x. And that's how you've got to start. It says find the formula for y in terms of x and work out the missing values for each. Okay, so we are given a value for x and a value for y. Now you must substitute these in and make sure that you do put 72 down for y. And make sure you put 6 down for x. So k x squared means k times x squared. And in this case, I'm substituting x and replacing it with 6 squared. Okay, so then it's just a case of rearranging things to get the value of k. I'll take my time on the first one. 6 squared is 36, so multiplying by 36 on the right, divide by 36 on the left. You've got a value for k, so therefore, or it implies that k is equal to 2. Okay. Now, what we do then is write down y equals whatever I worked out k to be. So I'll replace k with 2 times x squared. So I don't need to put the times in. And that's the first sort of like normally 3 marks, okay, as you'll see in the questions further on. So then I go on, and try and work out now what this value of y is if x is 5. So I'm using that formula. So it's often part B, so this is often part A, as you'll see further down. So y equals 2. Now I am replacing x squared with, I'm replacing x squared with 5 squared. So 2 times 5 squared. Now we know the 5 squared is 25, so y is equal to 50. And that would normally be the second mark. Okay, part C then. I'm given that the y value is 98, so I'm substituting it in this equation. So I'm replacing y with 98. And then 98 equals 2 times x squared, 2 times x squared. Okay, so it's just a bit of algebra then to rearrange. Multiplying by 2 on the left, or on the right. When I take it over to the left, I divide. So 98 shared by 2 is equal to 49. So basically 49 equals x squared. Now, this is something to watch out for. If you were doing Pythagoras' theorem and we're just talking about the length, you're able to say that x is the square root of 49, which is 7. But of course, minus 7 times minus 7 is also 49. So there's two answers. You've got plus 7 or minus 7. And if you miss that, I'm afraid at higher tier, you won't get the mark. Okay, there's two answers. 7 times 7 is 49. We've all known that. And minus 7 times minus 7 is also 49. And that's typical of a question that you would get in your GCSE non-calculator. There's a second one I'll show you, then you can try a few questions. So on this occasion, y is in direct proportion with x. So we start off with a statement, y is equal to some constant times x on this occasion, not x squared. So we substitute what we've got for y and x down here, making sure we substitute the right way. So basically I could rearrange that and tell you that k is equal to 4. Okay, so I then are able to say that the formula is y equals, and I replace the value of k with 4 up here. So I say y is 4x, and that will get you 3 marks more often than not. Okay, so that's part A. Part B, y is equal, what's y when x is 7? So I now use this formula, having derived it, and I say y equals 4 times the value of x is 7. And part C, I've given the y value is 10, so I make sure now I replace this y with 10. And rearranging it, x is equal to 10 divided by the 4. In other words, x is equal to 2.5 or 2.5, or whichever way you want to say that. Okay, now those are two questions I've tried. They're both, I would say, non-calculator, unit 1. I'm going to put two questions here. Now, as is always the case with these, I'll create a bit of there's two questions there. I'd like you to have a go at them, or at least familiarise yourself with them. Unfortunately, I'm not going to give you a great deal of time. You'll need, as you know, with the webinar, you'll need to pause it and press play again if I haven't given you enough time. Okay, so you crack on. Okay, I'm aware I haven't given you a great deal of time, but you can pause that screen. Okay, so this is what you would need to do here. Starting point is y is in direct proportion to the square of x. So you start by saying y equals k x squared, just like the very first question. Replace the value of y with 20 and the value of x with 2. If I rearrange that, I end up getting that k is equal to 10, and therefore my statement, my equation connecting y and x is y equals the constant that I'm trying to find out is 10x squared. Sorry, I missed something there. 2 squared, okay, and 2 squared is 4. And if I share 20 by 4, I end up getting that k is equal to 5. Okay, very easy to make an error like that under exam conditions, perhaps. So k is equal to 5, I end up with 5x squared. However, I don't know if you did make that error. I could carry that error forward and you could get the remaining 2 marks. But hopefully let's get it right. Okay, so part B, I'm using this formula. So I'm replacing x with 3, so y equals 5 times 3 squared. Now 3 squared is 9, so I'll just say that y is equal to 45. 5 9s 45. Okay, and part C, y is 180, so I replace y with 180, it's 5 times x squared. So I'm multiplying by 5 on the right. When I take it over to the left, it's 180 shared by 5 equals x squared. Not as bad as you think. You could divide that out. You could do 5 into 180 and you get 36. So 36 equals x squared. And once again, like I said in one of the questions above, we can have 2 answers. X is 6, is the square root of 36. It can also be minus 6. And if we miss the minus, I'm afraid you get it marked wrong. There's 2 answers. Okay. Question 3. The cube of x. So we do this. Part A, y is equal to k, some constant, times the cube of x. Okay, got to start that off correctly. If you miss it, like I did initially in question 3, you're not going to get any marks. But it's equal to the some constant times the cube of x. So I replace y with 250 and x with 5. So 250 k times 5 cubed. Now 5 cubed is 125, and k is therefore equal to 2. You could take a bit longer to do that if you wish, but that's 125, and I can see 125 goes into 250 twice. Okay, so therefore the statement that links y and x is y equals 2. I'm replacing k with 2, x cubed, and that's part A, possibly 3 marks. Okay, part B, I'm using that formula, even if I've derived it incorrectly, just using incorrect numbers or an error, I could carry on and get the remaining 2 marks. But if I've started off and I've said the wrong statement there, if I haven't put an x cubed, I can't get any marks. Okay, so for part B, y equals, I'm using this formula, 2 times an x cubed, I'm going to put 4 cubed. Okay, so you should know that 4 cubed is 64, so it's 2 times 64, y equals 128. Okay, and the last one, we're replacing y with 54, so there's question C. I'm replacing y there with 54 equals 2 times x cubed. So 54 divided by 2 is 27. 27 is x cubed. Now, the cube root of 27, again, is a number you should know, and it's 3. X is equal to 3, and I can write it that way or that way. Okay, there's no need for a plus or minus there, because the only way you can get 27 is to multiply 3 positives 3 positive 3's together. Okay, right, I think you should have a look at question 5, and I'll same thing again, pause the screen if you need to, on question 6, and when you're ready, I'll run through them. I should mention there's a unit 1 here, meaning it's paper 1, then non-calculator. Okay. If it's unit 2, you need to get a calculator out for it. Okay, so pause the screen if I haven't given you enough time. I'm going to try and show you how to do these 2 questions. Question 5. Y is directly proportional, so it's y equals k times the square root of x. So you've got to get that right. It's the square root of x. Some constant times the square root of x. So now I'll substitute for y. It's always the same process. And I'm replacing x with 16. Now, you all know the square root of 16 is 4. So 12 divided by 4 is equal to k. So in other words, k is equal to 3. And we have a formula y equals 3 times the square root of x. Okay. I go on and use that formula for the next question. Part B. Y equals the constant, which I've worked out down here to be 3 times the square root of x. And conveniently, it's non-calculator. You know the square root of 81 is 9. That's what you get, 27. I should mention here, the square root of 9, I nearly missed it again. It's a common thing that not only students but teachers miss as well. The square root of 9 gives 2 possible answers. You could get plus 9, which would give it an answer of 27. You could get minus 9, so plus 27 and minus 27, because that's what you got. 3 times 9 is positive 27, and 3 times minus 9 is minus 27. I often miss that, okay? And it would be marked wrong. Question C, y is 48, so 48 is equal to 3 times the square root of x. So 48 shared by 3 is 16 equals to the square root of x. Now, the way I get this answer here is I square both sides. Because if I square x, I've got, if I square x, I've got just x. And if I square 16, it's 256. You may be allowed a calculator for that. I've said unit 1, possibly unit 2, but you should be able to multiply 16 by 16 to give you 256. Okay, I'm going to look for question. I'm going to skip question 6. This one is again non-calculator. I'll do question 7. Okay. Right, question 7. Y is equal to proportion with x, so k times x. So replace y with 4 and replace x with 2. So it's very easy to see that k is equal to 2. And therefore, the equation is y equals 2 times x. Okay, now for part B, you have to work with decimals. Y equals 2 times the value of x is 0.6. So that's quite straightforward. Y equals 1.2. And question C, right, this might look horrible, but let's see. This is where, yeah, this is where you probably may need a calculator. It depends how awkward the examiner wishes to be. But the value of y is 0.0135 equals 2 times x. Now, therefore, x is equal to this value divided by 2. Okay, so you'd be expected, this is why I think it's non-calculator, you'd be expected to be able to do 2 into. That wouldn't be unreasonable. 2 into 0. 2 into 0, 2 into 1, carry the 1, 2 into 13, 6 2s are 12, carry the 1, and 2 into 15. 7, carry the 1, 2 into 10 is 5. So the answer for x, 0.00675. Right? So the beginning was very easy, and I think this was okay. The numbers were a little bit more difficult there. I'll tell you what I'd like to do. I'd like to look at yeah, we'll look at this question here. There's 1 or 2 worded practical questions, and then we're going to look at indirect proportion. So you have a look at that a moment. Pause the screen if you need. Okay, so we'll have a look at this and then a couple of practical questions, and I've got a second sheet. Okay, so again, I'm suggesting this is non-calculator. So y equals, there's no part A and B, but it's effectively part A, B, and C on this, right? Okay, so y directly proportional to x, so that's a nice easy one initially. The numbers I got are 18 and 3, so 18 equals some constant times 3. So it's 6, isn't it? K is equal to 6. So therefore, the statement or the equation is y equals 6x. Okay. Sorry. And yeah, have a look at this. I've replaced y with 3. Y is not 3. Sorry, I've replaced y with 18, and I shouldn't have done. I should have replaced y with 3. So it's very easy for me to carry on in this vein, and I wouldn't get a mark because I substituted it the wrong way round. I wanted you to see that. Very easy mistake to follow into. Y is equal to kx. The value for y is 3, not 18. So we're going to have a fraction answer here. So 3 is equal to the k times the value of x is 18. So leave k there. And it's 3 over 18, or better known as 1/6, right? So what we end up saying is y equals, and that's 1/6. Okay, y is equal to k times x. So I've replaced k with 1 over 6. Perhaps it's 1/6 x, like that is probably the best way of saying it. Okay, now as I say, I'll come back to it. The y value is 3, the x value is 18, so I have to be very careful when I put that together. Okay, I showed you how to do it wrong, now I've shown you how to do it right. If there was a part B for this, again, I'm going to use this, y equals 1/6 of the x value there, and that's easy. The next one here, y is 7, so y equals to 1/6. Sorry. Again, the y value is 7, so 7, let's draw a line here. The y value is 7, not the x. The y value is 7, 1/6 times x. Okay, so I'm multiplying by 1/6 on the right. When I take it over to the left, I divide by 1/6. So 7 divided by 1/6 is the value of x. Now we know this 1/6 in a whole number, 12 in two whole numbers, and eventually 42 is the answer. Okay, because when you divide by 1/6, you multiply by 6, so x is equal to 42. Okay. And the last one, let's make sure I do the x and y correctly this time. Y equals, and I've got the value of x is 102, 1/6 times 102. Okay, and I would do it up here. So 6 into 10, ones carry 4, and then 7. So the answer, and you would need to go and write these down in there. So 17, 42, and 2. Okay, so very careful in the way you substitute x and y, especially at the beginning. So there's a couple of questions now that are more practical, worded questions. The first one, so it's up to you what symbol you want to use. Okay, I'm just going to use the numbers, okay, and then I'm going to come up with a formula that links euros to pounds. Okay, but there's a number of ways of doing it. I'm suggesting it's a paper 2, so you're allowed a calculator. So 50, the statement is £50 is equal to some constant. Sorry, say it the right way round. 90 euros is equal to some constant times 50. So something times £50 gives us 90 euros. So what you do is this, 90 divided by 50 is the value of k. So k is actually 1.8. Let's create a bit more space here. Okay, so we've got, now it's up to you which way you want to word it now. So I'm going to say the euros equals 1.8 times the pounds. Okay, like that. You might put symbols in or whatever, but you always get the euros by saying 1.8 times the pounds. So now it's the case of saying, right, how much is 175 pounds worth? So I'm going to replace the pounds with 175. So to get it in euros, it's 1.8 times 175, and this is where you need a calculator. And I look down here, it's 315 euros. Sorry. Yes, it's 315 euros. Okay. Right, have a look at this one. I find these a little bit different from above. They're not as predictable. The questions I've done above are very predictable. We'll have a look at this. A painter can paint 15 fences in 6 hours. Now this is paper 1, because I think the numbers are quite easy. How long will it take him to paint 40 fence panels? There's half a dozen ways of doing this, but I'll try and stick to this method that we're doing tonight. I'll pause for a moment for you to try them. Okay, I haven't given you much time, but you can pause if you need more time. Okay, so to get 15 fence panels, you multiply the time, which is 6 hours, by something to get 15. So if you divide 15 by 6, it's 2.5. So K is 2.5. So therefore, to get the number of fence panels, okay, the number of panels, so whatever wording you wish, the number of panels is always 2.5 hours, 2.5 times the time, right? You paint 2.5 fence panels every hour. So if I want to work out how long it takes to paint 40 fence panels, you replace the panels with 40 times the time. And when you divide 40 by 2.5, okay, you end up with 16 hours. Okay, so there's more questions that I'll leave on the answer sheet that will be provided after this, but I think I need to move on to direct proportion. Sorry, indirect proportion, right? So this is called inverse or indirect proportion. Okay, inverse or indirect proportion. Okay, and basically, as one value increases, the other value decreases. Now, given I think a very good example, the value of a car, most cars now, not vintage cars, as the age of a car increases, so as it gets to 2 or 3 year old, the value drops. As it gets to 10-year-old, it's dropped to a hell of a lot less. So a car's value decreases, and this is inverse proportion. So I'm going to show you a couple of questions. You must learn these. Y is inversely proportional to X. This is what you write. And if you mix it up with what we did on the first sheet, you won't get any marks. It's inversely proportional. So this constant is a constant over X. I mean, it can be written like that, but I'm going to move on and crack on with the actual questions. Okay, so all of these have some constant over either X or X squared or X cubed or the square root of X. So let's have a look at a question. Typical question, paper 1. Y equals some constant, because it's inverse proportion, over X. That is the link. It's not K times X, it's K over X. So what we've got, I replace Y with 2, being very careful. Replace X with 5, make sure they're the correct way around. Now obviously K then equals 10. And if K equals 10, I then replace K up here in this formula. So we end up saying Y equals 10 over X. And that is our statement. Okay, once I've got that, I then have a look. I use this formula, Y equals 10 over whatever X is, and X is 20 in this case. So Y equals 1/2. Okay, I'll do another one. Okay, part A, y equals inverse proportion or indirect proportion with a square of x. So what you do is saying k over x squared. Y, I'm going to use the values from here, make sure I get the right way around. Y is 20, k and x is 3, so 3 squared. So therefore, that value is 9, dividing by 9, take it over, times by 9, we end up with k equals 9 times 20 is 180. So you end up with a statement that y equals 180 is the value of k, and replacing that over x squared. We go and use it in part B. I've got the value of y, sorry, value of x is 6, so y equals 180 over 6. That's not so bad. 6 into 18 is 3 times, stick a naught on the end. And part C, I've given that y is 45, so 45 equals 180 shared by, so 180 shared by x squared. Oh, I missed something here. (180) shared by x squared, 180 shared by 6 squared, not 6. So it's 180 shared by 36. Okay, so you can tap that out on a calculator or not. 180 shared by 36 is 5. Okay, it might take a bit longer without the calculator. On the next question, y is 45, so it's 45 is 180 over x squared. You swap these over, you rearrange them, x squared is equal to 180 over 45. Now then, how many 45s go into 180 is 4, so x squared is equal to 4. And we'll come back to what we were doing on the first sheet. So x has two values, has a +2 and a -2. So I think you should look at these two questions. If you can, pause the screen and press play when you're ready. Okay, I'll have a look at this question then. If I haven't given you enough time, pause the screen. So y equals k upon x, inverse proportion with x. Okay, y is equal to 12, k upon the x value is 3, is 2 rather. So obviously k is equal to 24, and we end up with a formula that y equals 24 upon x. Okay, 24 upon x. Now, if y is 24 upon x, I go and use that for the part B. The value for x is 3. So 24 shared by 3 is 8. For the part C, I'm replacing y with 96. So down here, y is 96. 96 is 24 upon x. Swap these over, the 96 and the x, so you're rearranging. X is equal to 24 upon 96. And you could cancel those down, they actually come to a quarter. All right. Now, I am going to look at one question that's practical, right? Worded question. A computer downloads information at a rate measured in, I think it's megabits per second, okay? The download time is inversely proportional to the megabits per second rate, okay? A particular file takes 12 seconds to download at 2 megabits per second. So what it means by this, right, is I'm coming up with time is inversely proportional to the rate, okay? So what I'm going to end up doing here is saying, yeah, I'm putting my own words in, some constant over the rate. Time is inversely proportional to the rate. So if I replace time with 12, I'm going to have to create some space here. If I replace time with 12, 12 is equal to some constant and the rate was 2. So rearranged, the constant is 24. And therefore, the formula is the time will always be, what is the constant? 24 over the rate. And that's our formula. The time is 24 shared by the rate. So if we just apply it to the very first question here, time is equal to 24 shared by the rate. The rate for this very first question is 6. So if I'm downloading at 6 megabits per second, the time that it will take is 4 seconds. Okay. Now, I'm just going to summarize very quickly. I have got a sheet, but I've mislaid it. So I'll just refer to both slides here. The key is you have to know when you are working with inverse proportion, these are the things you must learn. Y is inversely proportional to x, or indirectly, there's two words. Inversely proportional to x cubed there, and we're inversely proportional to the square root of x. That's inverse proportion, or indirect proportion. The very first sheet I gave you referred to direct proportion. So you have to learn it this way. Okay, y is directly proportional to x. Directly proportional to x squared, x cubed, and square root of x. So you must start off by making that statement. Then you replace the y and the x values with what you are given. You come up with an equation. And when you come up with an equation, go and use the equation for part B and C, or filling in the table. Okay, so that's it for now, and I hope that's been beneficial to you. Thank you.